So here we're looking at an example of our linear cost, revenue, and profit functions. Now in this example, we have that at a homecoming game, the math club is selling lemonade for $2 per cup. Now, the cost to rent the booth at the homecoming game is a fixed $120. Now, the club knows that the supplies, the lemons, the sugar, and the cups collectively is going to cost 50 cents per cup of lemonade. Now, our job is to take this information and use it to write a linear cost, revenue, and profit function for producing and selling X cups of lemonade. So to get started here, let's simply think about what are we given? Now we know from part A that we're going to let X be the total number of cups of lemonade being produced and sold. Now, reading back through the question, we can see that the math club is going to sell these cups of lemonade for $2 per cup. So that's our selling price. Now, we also know that it's going to cost the math club a fixed $120 to rent a booth at the homecoming game. And last but not least, the club knows that the supplies are going to collectively cost 50 cents per cup. So this is going to be our variable cost. So with this information, we're officially ready to start setting up our functions. We can recall that our linear cost function is defined as the variable cost times the total quantity plus the fixed cost. So we can say that our total cost function, C of x, is going to be equal to 0.5x plus 120. Let's now recall what we know about revenue. So recall that the linear revenue function is defined by price times quantity of items sold. So given this information, we can say that our revenue function, R of x, is going to be equal to $2 times x, the number of cups of lemonade sold. And last but not least, we want to define a linear profit function. So recall that linear profit function is defined as revenue minus cost. So taking the two functions we just found, we can define our total profit as being equal to 2x minus, now again, remember to use your parentheses for safety, the cost function. So 0.5x plus 120. Again, we use our parentheses for safety here to remind us that this negative not only goes to the variable cost, but must also be distributed to the fixed cost. So this leaves us with a final answer for profit P of x being equal to 1.5x minus 120. So now that we have our cost, revenue, and profit functions, let's go ahead and look at part B. In part B, we are asked to determine the number of cups of lemonade that must be produced and sold for the math club to make a profit. Now, let's begin by recalling that the break-even point is the point where revenue is equal to cost, or in other words, where the profit is 0. So by using the break-even point, we can determine how many cups of lemonade must be produced and sold to have, or for the club, to earn a profit of $0. So to solve for x here, I'm going to go ahead and set profit equal to 0 and then solve for x. But keep in mind that you could also set revenue equal to cost and solve for x and still get the same answer as long as your algebra is accurate and consistent. So you have our profit function, which is 1.5x minus 120, and we're setting that profit function equal to 0. So to isolate x here, we'll start by adding 120 to both sides of the equation. Now we have 1.5x is equal to 120. And again, to isolate that x, we'll divide both sides here by 1.5. Now, of course, we could now take out our calculators and plug this in, but what if you didn't have your calculator? So if we didn't have our calculators and we wanted to do this by hand, to get rid of that decimal, we can multiply the numerator and denominator here by 10, which gives us the equivalent 1,200 divided by 15. And we know that 15 goes into 120 5 times with a leftover 0. So what exactly is this telling us? That x is equal to 50. Well, recall that this is the break-even point. At x equals 50, the club has earned a profit of no dollars or $0. So in order for the club to make a profit, we need at least one more unit than this. So in order for the club to make a profit, they must produce and sell at least 51 cups of lemonade.